Okay, and what happens is once you calibrate, before you use it, it needs to be calibrated. For the calibration, you can see the numbers over here. That is detecting the time, how long it takes to travel the pulses from one end to other end, right? So that needs to be 25.5 microseconds. Okay, so when we, for example, now over here, whether it will have 25.5 or not. But only thing is that when you use the silicon for better contact, right, then keep the transducer opposite to each other. Okay, once you keep them opposite to each other, see, you got the readings 25.5 microsecond. Okay, once you have that 25.5 microsecond, then that is calibrated. Once it is calibrated, now it's ready for you to use for your samples. Next is how it can be done. Here in the board, you can see the velocity. This Pandit test will tell you the time required for pulses to travel from one end to other end. Okay, so if you are keeping your transducer on the opposite side of the cube, it means what is the distance? 100 millimeter cube. That's why that is the 100 millimeter, isn't it? So velocity, the formula for velocity is distance over time. So distance is in millimeter, that is 100 millimeter, and the time that you can get it from here is in microseconds. Okay, so distance you need to convert into kilometer, and time you need to convert into second. Okay, so you have how you convert microsecond to second is by multiplying microsecond by 10 to the power minus 6. So that you will get the velocity in kilometer per second. Once you get the velocity in kilometer per second, then you can compare that velocity according to the chart supplied by the British Standard. So here, to know the quality of the concrete. So your velocity is, if that is less than 2 kilometers per second, the concrete quality is very poor type. And if it is more than 4.5 kilometers per second, that is excellent quality of the concrete. Now, you got the velocity. So that is how you will use, or this Pandit equipment is used to know the quality of the concrete. And that is not only one method or that purpose of this equipment. It has also advantage to know the defect inside the cube, if there is any cracks or gaps present inside the cube. What happens is, if normally what the pulses passes very straightly from one end to other end. If it has got gaps, what happens is the pulses will deviate its path, and when it passes or deviates, the time it will require longer than the straight when it travels, isn't it? So it means when you are getting the values, for example, constant or consistent with 20, 20.5, 20.4, something like that, one, it's okay. But if the values jump to the 30, 20, then 30, 35, it means it has some defect inside the cube because it has gap and the path is deviating, right? That is how it will detect the gaps or cracks inside the concrete. So you have got two purposes for the Pandit. One is to know the quality of the concrete and to detect the cracks or gaps inside the concrete. That is the use of the Pandit. Any questions so far for the Pandit test? Any questions? No?
No.
Right. So we will see how it can be done, right? It has already been done. Only for the better contact, use the silicon. Now, we're going to take the 3 readings, select the smooth surface. Now, 3 readings, first at the center. Once you put the transducer opposite to each other, press it, right? Then you'll get some readings over there. What's the reading now? 21.1 microsecond at the center. Then move it to the top side, but not to the edge, just 10 millimeter below from the top side. Then get the second reading, that is 20.4. Second reading. The third reading is 20.9 microsecond. Did you get 3 readings already? Right. So that is for cube number 3A, and let's do for 3B as well. Again, put some silicon. You have it. Right. The other one for 3B is 20.6 20.4, 20.5, 20.6, sorry. That's a fluctuation. Right, okay, you got 3 range topics, right? Now, from this one, you got this one in microsecond. Now, are you clear with these things? What should be done to calculate the velocity? Okay, so you got microsecond, convert that to the second, and velocity comes in kilometer per second, then compare that to the quality of the car. Okay, let's go. So, this is about the quantity test. Now, the second method NDT test is using this rebound hammer. This rebound hammer, or you can say the Smith hammer, just its name. This rebound hammer is used to know the hardness of the concrete. Okay, so how it can be used is, this is the trigger system. Once you release the trigger, it will give you the rebound from the surface of the concrete. And once you lock it, you will get some sharpened readings on this hammer. For example, now from this one, how much you got is 30, 40. You get this number over here, 40. This is the rebound number from the surface of the concrete. Then, luckily we have got the graph in the hammer, right? Most of the hammer, some of them will got, or some of them doesn't have the hammer on the chart. Once you have that chart, or if you have that chart, what you can do is convert that rebound number to get the strength of the concrete. Okay, so you have your rebound number in the x-axis, and in y-axis you got the strength. For example, now, and you can see now there are 3 diagrams and 3 lines. These 3 diagrams are these hammers, how you have used. Either that you have used vertically downward, horizontally, or vertically upward. See, upward, when you use that one for the ceiling, and for the slab, that's downward. In the columns, you can use the horizontal positions. And accordingly, if we are using here now is vertically downward, it means for 40, it needs to go or select the line upper one, isn't it? And to convert that to the strength, go to the y-axis and get the number over here. For example, for 40, it is around 44 Newton per meter square, right? Only thing is that to get or to compare the strength of the concrete using this hammer and using that composite testing machine, this hammer needs to be calibrated. Without calibration, the strength that you are converting from this one may not be the equal to that from the strength machine. Okay, so it needs to be calibrated because in the market you will get different different energy type of the hammer, and accordingly you use for the concretes. And in that case, or you need to calibrate from the concrete casting, from the starting of the concrete casting, so that you can get the equal type of the strength. Okay, so only thing that when you use this hammer, the sample needs to be fixed. If you are not fixing the sample, you cannot get this one, right? Because it will move. So what we need to do is we're going to keep that sample into the machine, and once we load some over on the strength of the machine on the cubes, then we're going to apply this hammer to get certain rebound number, and we'll convert it and check whether those two are by how many they are different. Okay, so that's all about the rebound hammer. Any questions regarding this one? Rebound hammer. Okay, that's fine. Now the other thing is density. The strength of the concrete depends upon the materials property, water, that's we are telling since the beginning of the classes, water cement ratio, material properties, and density of the material as well, or the density of the concrete. So if you don't have proper vibration when you are doing the casting of the concrete, you may not have the proper density of the concrete. You may get some voids inside it, right? If you don't have the good density of the concrete, you will not get the target strength of the concrete. Okay, so we will check what's the density of the concrete. Normally, density of the concrete can be calculated in 2 ways. One is just measuring the length, breadth, and height. That will give you the volume, right? And mass of the concrete, right? So mass density is mass by volume. So mass and this measurement will give you the volume, and mass divided by volume gives you the density. That is one way. The other way is water displacement method, which is more accurate than using the measurement method. Okay, so we are going to do the water displacement method, in which we need to have some steps to calculate the density. First, we will calculate for the volume. For volume, we need to have the mass in air and mass in water. So mass in air minus mass in water divided by the density of the water, which is 1000 kg per meter cube. That will give you the volume in meter cube. Once you have that volume, then density is mass in air, which is the same one over here. You got it, right? Mass in air divided by the calculated volume from here gives you the density in kg per meter cube. Normally, your density or the concrete density is 2250 to 2450. That's the range between that of the concrete. Now we will see what's the density of this concrete cubes then, right? So we have 3A and 3B, and we will check. We will get the two readings for mass in air and mass in water. So first of all, here it. Question number 3A, mass in air. Right, the first one is 2368.0 grams. 2368.0 grams. That's 3A. And 3B. Again, check that is clear or not. If that's 0, that's one. There it. Second one is 2402.0 grams. 2402.0. Well, that's it. Maybe hydrogen down there. Okay, that's done. So that is mass in air. Now, to get the mass in water, just lift the bucket up and submerge the empty bucket into the water. So here you have mass in the bucket. That's the bucket already filled in and submerged into the water. Only thing is that this bucket should have touched the bottom of this bucket. Okay, there is some floating conditions. That's fine. Now, again, tear it. Let's get the mass in water. So it's 0. That is 1368.5 grams. And 0. One 1394.0 grams. So we got both readings, mass in air and mass in water. I hope we can now calculate the density. Right? Any questions so far for the density calculations? No. Right. Now the next step is to find out the strength of the concrete using the destructive way. This is the compressive testing machine. It's a compressive strength testing machine where you can see the ramp. Once you apply the load, the ramp will come up and cross the tubes. Now what happens is, when you put the concrete tubes, normally it should be, you select a smooth surface on the top and the bottom side of the ramp. So, and keep it at the center of the ramp. Then we will select the rate of the ramp, that is 6 kilonewtons per second. Okay? And what happens is, once the concrete tube will be crossed, you will get the peak load. And that peak load divided by the contact area. Now you can see the contact area. These are the area, contact area. So how we calculate? When the ramp comes up over here, that is the area. Area is length times breadth, which is 100 millimeter by 100 millimeter, right? So once you cross the cubes, you will get the peak load, and that peak load is in kilonewton. If you convert that kilonewton to Newton and divide by the area, you will get the compressive strength. Okay, that's the formula over there. Compressive strength is peak load divided by contact area. And our target strength is 30 Newton per millimeter square after 28 days. These tests are doing for 14 days, which may be around 60 to 70% of 28 days strength of the concrete. We will see what will be the strength then. Okay, so at the same time, I will give you 3 readings for this one as well. Once it will be fixed, we will get some readings. Right. 22, 24, 24. 22, 24, and 24. Let's say 23. Now we are using the horizontal direction, right? So 23, if you go 23 somewhere around here, and we are going to select this line, isn't it? Horizontal. So if we going to convert that one to a strength, we got 12 Newton per millimeter square. And 12, since this is not calibrated one, the result is not comparable from this one, right? So this is just our idea how it will be used. Now the maximum load over here is 341.29 kilonewton. Write it down. 341.29 kilonewton. Did you get it? That is in kilonewton. So that peak load for your compressive strength, that peak load kilonewton must be converted to Newton. And if you divide that by the contact area, 100 millimeter by 100 millimeter, you will get that strength. And that you will compare it with our target strength, which is C30, 30 Newton per millimeter square. Okay? Right. That's the first one. Again, second one. And I'll give you another 3 readings again. Thirty.
36.
20.
20.
And let's keep going. 38.
38.
32.
32.
Can I see that readings over here? 30, 36, 38, 32. 4 readings, ready? Or 5?
The 20 as well.
20 as well, isn't it? 20
Okay.
as well, yeah. So just what you do is just get 3 readings, 30, 36, and 32. Ignore 30, 20 and 38. Right, the peak load for this one is 360.80. 360.80. Okay? So you got the peak load for this one, again, and what you got the readings for the hammer is you got 3 readings, get the average of that one, and convert that one to over this one, right? That's just for a demonstration. Okay? Right. So now, after that one, for analysis of the concrete cubes, how it has been broken, or see, the code will say that the satisfactory and unsatisfactory test of the compressive strength of the concrete cubes. After testing, if the concrete cube looks like this one, the zigzag way over here, right? So you can see the zigzag thing over here.
Yeah.
That's okay. That's fine. And if you peel that off, you will get the conical shape like this one. And again, if you take the part of that one, you will get the pyramid shape. If that is the conditions, then that is the satisfactory testing of the concrete cubes. Now the other thing is checking how it has been felt. There are two ways how it will be felt. Most of them many ways, but normally two ways: shear failure and the bonding failure. If the concrete fails with the shear failure, that will be the stronger type of the concrete. If it fails with the bonding failure, that will be the weaker one, right? Because in the bonding failure, what happens is the bonding between the materials will be very weak. There will be no bonding between the materials. That's why it will be very weaker type. But in the case of the shear, it needs more strength. For example, see, if you see from the car, that's a conical shape, but it needs to get more build off from that one. And other thing is that if you check that one aggregate over here, then you can see that the part of the aggregate is already been sheared, right? And if you find more something like gaps over here, the part of the space over here for the aggregate, that's the bonding. So if you have more predominantly bonding, this type of the gap over there, that is the bonding failure, which will make the concrete weaker. And if you have predominantly shear type of the failure, that is the shear failure, and it will be the stronger one. Here you can see that's the predominantly shear failure. Okay, that is how you will analyze once you cross the concrete. Okay, any questions, Shafar?
No.
That is all about the destructive and non-destructive test of the concrete.
So if they both used in conjunction, then you would use the non-destructive first, and then you would.
Not necessarily. You will, for example, sometimes what may happen is you need to test the concrete only for the non-destructive. You don't like to destroy the concrete. In that case, you're going to do the NDT test. But after all, the effective type of the strength will be achieved by compressive strength. That is after 28 days.
Also, the rebound hammer. So you use the rebound hammer in both then. Okay. So what happens?
Both end, yeah, you can. Normally, it needs to have in the both end, right? And needs to have 9 times, minimum of 9 readings. We have got only 3 because of time. Just for an idea. And from 9 readings, you will get an average, and from that one, you will find out the hardness of the concrete. Okay, right? Good.
Okay.
So, if you have any questions, other questions, you can comment anytime.